Hey guys, it's about 7 a.m. I need to get up, make some breakfast, and head to school, where our first lecture is History and Philosophy of Technology. It's actually where I meet Aleš, so let's get up and not be late. So I'm at the parking lot near the school. It's almost 8 a.m. and I met my friend. However, Aleš is not here, so I don't know where is he. I hope he will come soon. What's taking him so long?
Hello. So it's about 7 a.m. and I'm going to school. It'll take me about 1 hour actually to get there. Even though I live in Brno and the school is also in Brno, it takes quite some time to get there. But I like my time well organized and I don't like to waste any of it. So I have things like planned. Tonight's going to be a very busy day. And first I'm gonna meet Vašek at the parking lot in front of the school. So let's get there.
Good morning, Aleš.
Good morning.
How are you today?
Quite well, I think.
Aleš, what time is it?
It's 8 a.m.
No, it's 8 a.m. and 5 minutes.
Okay, so something after 8 a.m. But it's a good time to go to school, I think.
What is our first lecture today?
The first lecture is about the history and philosophy of the technical engineering and of the technique as well.
Do you like this lecture?
Yeah,
do you think it's interesting?
I actually like it. I think it's very interesting to know the history, so you can get advantage of the history and apply some of its inventions to the future and the present as well.
Alright, let's get to it.
A few moments later.
I actually like it. I think it's very interesting to know the history, so you can get advantage of the history and apply some of its inventions to the future and the present as well.
So, the lecture is finished and now we are heading to work. We actually work at the License Corporation.
Yeah, we are very lucky that the building where we work is very close to the building where we study. So it takes about 5 to 7 minutes to get there. And actually something about VoiceSoft. VoiceSoft is concerned with printing management. So it enables the management and security of the printing jobs on the multifunctional printers, as well as copying, scanning, and not only 2D printers but also 3D printers.
It's almost 3 p.m. and now we are heading for the lecture Fuzzy Systems.
Yes, that's one of my favorite subjects.
And why so, Aleš?
Because it is quite a modern thing, I guess, and it also is something different than the standard logic, where standard logic only has 2 values it works with, 0 and 1, true and false. But the fuzzy logic extends this classic logic with all the unclear and fuzzy range of values, and that's how humans basically think about stuff. They don't think as true or false, but they have all sorts of different vague values for defining things. Alright, so now it's 5 p.m. and it's not over yet for us today. Now we're going for dinner, actually, I believe. Yes. to the, what's it called?
Mensa. And also we are relocating my car, so we don't have to go from work back to the school parking lot. Because our final class today is class from C# programming, and it's located at Purkinjova Street near students' apartments, which is quite far from our university. So we will go there by car.
Yeah, so after dinner we'll go to work again, and then after an hour from 6 p.m. to 8 p.m. we'll have this C# programming. So see you next time.
So Alex, what do you think about this seafood?
It looks very bad, but I guess I don't care even. I just need something to eat.
Now are we going to talk about what are we actually doing in our job? So Alex, what are we doing?
Okay, so our goal here is to create a robotic system or autonomous system that is able to test the multifunctional devices. So the multifunctional devices are just large printers that have an embedded terminal. So they have like the display which is embedded into the device. And what the robot is supposed to do is to tap the screen, the display, and this way control and make interactions with the device. And this way test its functions and test whether it functions properly. So the whole system consists of three main parts. First is the robot manipulator itself, which has the end effector in form of the stylus that taps on the screen. The second part is the image processing, and third part is the test definition. So we have lots of those tests, and each test does different actions. So, can you tell us something about the image processing, actually?
Yeah, of course, Alex. So, as Alex already implied, my main focus is targeted at image processing, or as we internally call it, improg. Improg provides robot an information about status of tested device. Without this feedback, robot will be able to operate at all. And why is that? That's easy. Because robot actions are made of individual steps that robot is making, and all those steps together creates a flow. And if any of these steps in the flow failed due to misclick or the screen not registering the click, the other part of the flow will be wrong. And that's exactly when improg comes into play. So you may ask, what is image processing, right? Well, I can explain it on a simple example. Let's have a picture, a color digital picture. Every picture has its resolution, right? Most likely nowadays it's 1080 to 1920, which is Full HD. This number is telling you how many points are in width and in height of an image, and every one of these points is called pixel. Each pixel has 3 channels, most likely: R, G and B, which is standing for red, green and blue. Each of these channels has value which goes from 0 to 255, where the highest value equals to highest brightness. So, for example, if you have 0 in red and 0 in blue, and highest value 255 in green, the resulting color, which is the sum of all channels, will be green. And the picture is nothing less than an array of these pixels. And if you wrap methods, algorithms and rules around these pixels, you can call it an image processing. Our improc contains several complex algorithms using descriptors and OCR to identify and recognize the screen and tell that to the robot, so the robot knows if performed action did expected result, and if not, so he could recover from it. OCR engine, that OCR stands for optical character recognition, which enables you to extract text and even its position from an image. I could talk here about descriptors and OCR and all our methods that we are using for several hours and maybe even more, but we don't have time for it right now. Maybe I will make a full presentation in the end of semester about it. But now let's switch to Aleš, because his work is as same crucial as mine, maybe more, because he's making the test. He's making that automation, right?
Right, it is. So my focus is mainly with the tests, but also with the actions that robot can actually do. It involves the basic tapping on the screen, but also more sophisticated algorithm. One of the more complex methods that the robot is able to perform is reaching a certain screen. So the device can display several screens, and there are several buttons that connect those screens basically. So if you tap a button, the screen changes. And a robot has this information in his database. It is required to be filled by a human, but a robot has the data in his database and he's able to find buttons that connect certain screens. And all of this autonomously, so you only say, like, robot, get me to this screen, and it is able to find a way, tap all the buttons required to reach this screen, and verify that it actually reaches correctly using the image processing. There are plenty other methods for operating with the device. We are also able to detect whether a paper actually prints out of the device using the sensors which can detect those papers, so we can verify whether the correct amount and correct type of paper actually rolled out of the printer. So many other actions. Now let's go back to the test definitions. A test is actually like the definition of consecutive actions that are performed individually, and each action must either be completed, or if it's not able to be completed, it must throw an error. So it is at a first glance obvious where the test ended and why. So if test ends with an error, I check where the error occurred and I immediately know why that happened. So that's very important, that the robot actually creates a log of its actions. So each action it performs creates a log, and I can always detect what happened during each test. And we have several tests for testing each action of the multifunctional device. So it has to be able to perform print operations, copy operations, and scanning operations. Those are the basic ones. And each of those tests contain different steps, but in the end they can all be performed autonomously, and no human interaction is actually required to verify that the printer is operating correctly. And this is important with all those changes that happen to the software that that ensures those printing, scanning, and copy operations. So it changes all the time. It develops, and even each day, it is required to be verified that it still functions properly. So if a human would have to perform those operations each day, it would be very boring and also time consuming. So he can do other actions while the robot actually does the testing himself.
Yes, Alish, that's the most important part, because the robot as is, and as we develop it, is a tool, and a tool for teams in Isoft, right? We are doing it to save their time, because if because they would have to do it manually. All these actions, all these tests, after every build, after every revision, they would have to go and test it manually. But with robot, they can just play and do some other works meantime, right? And even some actions are not performable by human, right? Because let's take an example. You have some stress test, and you have, for example, tabs, and you want to switch between them, yes? And after every switch, the device loads up the jobs again, and it creates some performance load. But you want to test if this performance load in some finite time reaches some critical value, right? But it's not after 10 attempts, after 10 switches, after 100 switches, or even after 1,000 switches. It can be after million switches, right? But there is no human on Earth, as far as I know, that will perform 1 million switches in finite time, because it's kind of boring, and I don't think no one can do it in time. So that's where the robot comes into play, because robot not only is not bored at any time, but he is also sleepless, and unlike human that works 8 hours a day, most commonly, a robot can work 24/7.
Also, apart from those stress tests, there are also measurement tests, which measure how long does it take for the application to load, for example, from your authentication until you see your print jobs on the printer. So how long does that take? Well, for a human to measure such duration would be very, very difficult and impossible to measure it correctly, because it takes roughly around 1 or 2 seconds, but we need more exact time. So using the robot and image processing, we are able to measure those durations very accurately.
But Alesh, you can also say that you can film it by yourself and then go to your PC and just check it frame by frame, and it is same accurate as a robot. So why to do it by robot?
Yes, that's correct, but robot can perform it hundreds or thousands of times consecutively, and then you can actually average the duration or something, or actually know how the duration changes with time. So it can actually increase, which is unintentional. So the robot can perform it many amounts of time, and autonomously you immediately see the results of the test. You can show it in the graph. So that's why, actually.
Well, to summarize it, the robot is, in our opinions, very useful for teams. It is time-saving and actually kind of cool, and allows testers to cover untestable areas which were untested yet, but with robot it is possible.
So this is what we do here in Ysoft, and hopefully we'll continue doing it.
So today's final exam or class is over, and I think we are both fucking tired.
It's actually 8 p.m. and since we started our day at 8 a.m. It's 12 hours. It's been 12 hours between school and work and everything. So I think we are very exhausted.
Yeah. So this was about one super busy day of busy students. Thank you for watching.
Yeah. Thank you. Bye.
Bye.
Okay, so what is your most favorite programming language and why?
Okay, thank you for your question, Alish. My most favorite programming language is C#. And why? Because C# master race.
And now I know I have to sing. To see chat spam angry.